Hello. This will be a demonstration of Proposition 26 from Book 9 of Euclid's Elements, which says that the difference of an odd number from an odd number is even. Or in other words, an odd number minus an odd number makes an even number. We're given two numbers, AB and BC, each of which is an odd number. And what we want to prove is that AB minus BC, that is the number CA, that number is an even number. We're going to begin by taking a unit away from our two given numbers. So from AB, we're going to take away the unit BD, leaving AD as the remainder. And likewise, from BC, we will take the unit BD, leaving CD as remainder. Now, because both of these numbers, AB and BC, are odd numbers, we were given that, it then means that if we take a unit away from them, as we have just done, we will therefore get even numbers, because we know from definition 7.7, which defines odd numbers, that an odd number is always one away from an even number. So if we subtract a unit away from an odd number, we will get an even number. So because we've taken a unit away from AB and we've taken a unit away from BC, the remainders, AD and CD respectively, will both be even numbers. But their difference, the difference of AD and CD, is the number CA. We also know from Proposition 9.24 that the difference of an even number from another even number is also another even number. And so if we take the difference of the even number AD from the even number CD, which is the number CA, that number, CA, will be an even number according to Proposition 9.24. And this is what we set out to prove, that CA is an even number, which means we are done with the proposition, therefore, etc. QED. Again, another simple one about subtracting odd numbers from odd numbers. The next proposition will be like this, and the previous two propositions were just like this. Nevertheless, I'm still going to go through an example. So say we have 7, which is an odd number, and we subtract from this odd number 7, the odd number 3. The difference will be 4, and what we want to show is that 7 minus 3, which is the number 4, is an even number. The key insight that makes this work is that if we subtract a unit from both of these, we'll end up with the same number. So if we do 7 minus 1, and we subtract from it 3 minus 1, that will still get us the number 4. And we can see that that holds, because 6 minus 2 is 4. Now 6 is an even number. 2 is also an even number. So we know from Proposition 9.24 that the difference of an even number from an even number is just another even number. So 6, an even number, minus 2, another even number, will produce 4, which is another even number. And so this is how we show that the difference of the odd number 7 from the odd number 3 is the even number 4, or in general, that an odd number minus another odd number makes an even number. That's all I've got to say about this proposition, so I'll end the video here and move on to Proposition 9.27.